Hello everyone, have you ever felt like time is passing way too fast and there's nothing you can do to slow it down? We often think of time as something constant, always ticking away beyond our control. But is that really the case? What if I told you that time isn't just an abstract concept, but something that can be stretched, slowed down, or even stopped under certain special conditions? So, what exactly is time? Is it even real, and how does it work? Many people believe that time is merely a concept created by humans to organize the sequence of events. In this view, time is just the gap between events happening. In religion, philosophy, and science, time is an incredibly important concept. It's always present around us, unfolding in a continuous, irreversible flow. While we can't see, touch, or taste time, we can measure it relatively well using clocks and markers like hours, days, or years. Since the early 1900s, people believed that space and time in the universe were two separate concepts. Space was vast and expansive, while time seemed unrelated to anything in the universe. Then, in 1915, Einstein's general theory of relativity unified three-dimensional space with time, forming a continuous four-dimensional spacetime. By demonstrating how gravity works, Einstein showed us how gravity actually affects time. According to his theory, the gravitational force we know isn't a force moving through space, but rather the result of space itself being warped, much like a rubber sheet sinking under the weight of a heavy object. The heavier the object, the more space and time are distorted, with the extreme case being space-time completely collapsing. The most famous example of this in the universe is black holes. So, any object with mass in the universe can distort the space-time around it. Time is no longer just a hypothetical concept describing the flow of the universe. It's a real thing. Time exists with different values in different places throughout the universe, and it can be distorted, slowed down, or even completely destroyed, just like any physical structure. We live in Earth's atmosphere and in a region of distorted space-time where the mass of the Earth has warped the space around it. A clear example of this is the GPS satellites orbiting the Earth, which need to make periodic time adjustments to give you accurate location data on your devices. Earth's gravity slows down time. The closer you are to the center of the Earth, the slower your time runs. This means that your head is technically aging faster than your feet. Just kidding. The length of our bodies isn't enough to make a noticeable difference. Besides gravity, speed can also affect space-time. The faster you move, the slower your time flows. Time for us is relative. We can't directly observe it, so to understand how time works, we can only study space. But from a physics perspective, space is just as tricky to understand as time. In the universe, or even within any atom, space is what exists the most. It's a foundational structure that forms all the matter we know. Many people think of space as nothing, but space is actually influenced by gravity. A clear example is the area around a black hole, where space is so distorted that even light cannot escape. Relativity predicts that matter falling into a black hole gets compressed infinitely as it approaches the center, known as the singularity, a point described by algorithms. Anything falling into a black hole simply has no way back. Inside the event horizon, space and time no longer exist. In other words, the immense power of gravity has destroyed space-time. From this, we can infer that space is not a unified whole. Space is assembled from smaller components that come together to form a vast structure spanning everywhere. Imagine space like water. Water is composed of 2 hydrogen atoms and 1 oxygen atom. If there was only one such combination, we wouldn't call it water. It takes billions and billions of such combinations to form an ocean. If some areas are frozen or evaporated, the ocean as a whole remains stable. Black holes are like objects that cause water to evaporate. In those places, liquid water does not exist but has transitioned to another state. Interestingly, space-time also behaves physically like water. It can swirl and create ripples when disturbed. Time follows the arrow of time principle, the continuous flow of the present, with the past behind and the future ahead. Time continuously moves forward and space continuously expands. Space forms continuously, linking together in an endless sequence. As long as time moves forward, space keeps expanding. The unity of space-time makes the universe strange and incredibly vast. Every component, seemingly empty, affects the entire universe. More than ever, we are aware that we live in the space-time of the universe and must follow its laws. We may try to think of ways to reverse time, but the truth is, space-time is too vast, and our abilities are limited. To summarize a few basic points about time, the stronger the gravity, the slower time moves. In places where gravity reaches its maximum, like the singularity inside a black hole, space-time doesn't exist or may have transformed into some other form. The faster an object moves, the slower its time flows. As an object approaches the speed of light, its space-time expands to preserve the speed of light. The speed of light in a vacuum is a constant that cannot be changed. How do we know that time is affected by gravity and speed? In scientific experiments, atomic clocks tick slower when they're closer to Earth and faster when they're sent into outer space. At high speeds like those of spacecraft, atomic clocks also tick slower. The concept of time is relative to the observer's frame of reference. Our brains also have a biological clock controlled by the suprachiasmatic nucleus, a tiny part of the hypothalamus responsible for our daily circadian rhythms. Certain neurotransmitters and drugs can affect our perception of time. When you're having fun, time seems to fly, while in emergencies or dangerous situations, time seems to slow down. The extreme distortion or complete destruction of space-time inside the event horizon makes black holes a monster that traps everything within. However, black holes are also the best experimental case for studying quantum gravity. Essentially, inside the singularity is where time comes to an end, and the problem is we can't imagine what state a particle would be in without time. Outside the black hole, the event horizon marks the boundary of time. Any particle that falls inside can never reverse its path. However, in quantum mechanics, every particle can theoretically be reversed, at least in principle. In 1970, Stephen Hawking applied quantum theory to the radiation field around black holes and showed that black holes have a temperature above absolute zero. Thus, they not only absorb, but also emit energy. When a black hole emits energy in some way, if you reverse this process, no particles escape. The black hole gains more heat, but what originally fell in remains trapped inside. This is known as the black hole information paradox. The black hole seems to destroy the information of the particles, whether you reverse the process or not. This means that if you had a time machine to go back into the past, anything that fell into a black hole would be permanently lost from our universe. Time reversal has no effect on a black hole, because inside the event horizon, space-time doesn't exist. This leads to an interesting theory. Could black holes be gateways to another universe? Whether that's true or not, recovering anything that has fallen into a black hole is impossible. In conclusion, space-time isn't just a theoretical concept, it's a dynamic entity in the universe, affecting everything from gravity to speed and energy. Mysterious black holes, space-time distortions, and the information paradox remain unsolved mysteries in modern science. While we don't fully understand how the universe works, one thing is certain: time and space have a direct impact on our lives in ways we are only just beginning to explore. Thank you for watching. If you enjoyed this video, please show your support by liking and subscribing. Don't forget to subscribe to Nothingverse for more in-depth explorations of the universe. See you in the next time.